Good morning, students. Today we will be doing a program in MATLAB for the generation of the sine wave using the MATLAB feature of the software and for the continuous and discrete time sine signals. So we'll be generating the sine wave for the continuous as well as for the discrete time sine signals. So first of all, for writing of these signals, we write a program in the M file, and for the M file we're using the MATLAB new feature, and we will open this new feature and we'll write the new script, and then we'll start writing the program in the new script. So first of all, we'll be using these two commands, CLC and clear all, for the writing the program. The CLC and clear all command is basically used to clear all the previous commands which have been written in a MATLAB window. So for clearing all the previous data, we use the CLC and the clear all command. Then we'll designate the value for the X and Y. For X, we designate certain value, and for the Y also we designate certain value of the MATLAB functions. Then we'll be using the subplot function for the MATLAB. Subplot function is basically used for plotting of the graph for the MATLAB function. For plotting of the graph, we use the subplot MNP command. Subplot MNP command is basically a MATLAB command which is used for the plotting of the MATLAB functions. So here they use subplot 211. Subplot 211 here stands for this number 2 stands for the number of rows, number 1 stands for number of columns, and this number 1 stands again for the plot number. So we have used the plot number 1, number of columns equal to 1 and number of rows equal to 2. Then we'll be using the command plot xy. Plot xy is used for the plotting of the graph between the x and y grids. After that, plotting the graph for the x and y, we designate the x label and the y label. X label is given as for the plot, for x label is given the designation value time, and for y label we have the amplitude. Okay, for x label we give the designation as time, and for y label we give the designation as amplitude. Then the title of the total graph for this continuous time sine signal will be equal to title. We give a total title to this graph, that is title is the continuous time sine signal. This is a complete one graph for the continuous time sine signal. So first of all, we have cleared all the previous commands. Okay, then we designate the values of x and y. After designation of the values of x and y, we'll subplot it. Subplot means we divide it into number of rows, number of columns, and the plot number. Then the plot function for the continuous graph has been used, plot xy. Then the labeling of that x and y axis, x label, y label. And after labeling, we'll give a total title to this graph. It's a continuous time sine signal. After giving this title of continuous time sine signal, we use a subplot function for the other graph, that is for the discrete time sine signals. Now subplot for discrete time sine signal is given by 212. 212 stands for over here is for the 2 stands for number of rows, 1 stands for number of columns, and again 2 stands for the plot number. Plot number is 2 over here. Then stem xy means we are using the plotting of the discrete time sine signals, and for plotting of discrete time sine signal we use a plot. Instead of plot, we use a stem function for using the discrete time signals. For discrete, we use the stem function, stem xy, and for this we plot our graph, and again we'll use the labels now for the x label and for the y label. For x label we use a time, and for y label we use the amplitude. And a total title of the complete graph is your discrete time sine signal graph. This is the total title of the discrete time sine signal graph. Now, after giving these values to this, we'll have a we need to run this program. And for running this program, we press on this run button and we easily run this program. Okay, class. So when we press that run button, a program will process and it will show the graphical representation of our graph. It is like this. This is for the continuous time sine signal, and this is for the discrete time sine signal. This one is for the continuous one. This is one for your discrete sine signal. So and they have put, over and this line that is over the fifth grid from for the fifth. And fifth grid we have the value of over here. See the value at 0.6. I have 0.6283, and for y we have the 0.951. Okay, so this is a specific value for the sine signal for the x and y axis when we take it for the any discrete time. Similarly, we have value for any time, any discrete values. So we have this negative also. For x we have 0.1 and for y we have negative 0.904. So these discrete values or the sampled values are only possible when we take the discrete time sine signals class. That is not possible with the continuous one. Continuous case, it will just give the broader idea that what is the maximum value and what is the minimum value. You can get the maximum value over here and we get the minimum value. Maximum value is 0.75 and minimum value is for y is we have the 0.998 and for x we have the 0.75. This is the maximum value. And for the minimum value we have, we can put a cursor over here and we get the minimum value. Minimum value is x is equal to 0.2388 and for y is equal to minus of 0.998. This is a minimum value for the x and y axis in case of a continuous and discrete times. So this is the major depiction when it is set.